Welcome, student, to finding the area between curves. In order to find the area between curves, we have to do the following. First of all, we need to sketch the graph of each curve. Second step, we need to find the intersection points. And third step, which is also important, we need to find the integration. Remember, the integration for the area, if it's given in terms of x, it will be just top minus bottom. So here we have top minus bottom, and that will be the area. First question here is we need to sketch and find the area of the region bounded by two curves, and actually those two curves are parabolas. How do I know they are parabola? Because actually both of them are of degree 2, as you can see here. And if we have parabola, we just need to sketch the parabola. Remember, in order to sketch the parabola, we need to find the vertex. And we need to find, is the parabola open upward or downward? For example, if you look at the one in blue, which is this one, the number in front of x squared is -1. That means the parabola will be downward. While the one in red, the number in front of x squared is 1, which is positive. That means the parabola is open upward. So if we sketch them, we have to sketch one that is downward, which is the blue one, and one looking upward, which is the red one. Of course, as you can see in the picture, they have been intersected into 2 points. We need to find them because those 2 points will make the limit of integration. So I need to find those 2 points here. How do we find the 2 points of intersection? We just make the function in blue, which is 17 minus x squared, equal the function in red, which is x squared plus 1. We make them equal, which means the two functions are exactly equal. So in order to find the intersection point, we have to make the two functions is equal. Now this is a very simple equation. Just move x squared to one side, move the -1 to the other side. We end up with 18 equal to x squared. Take 2x squared, or take 18 with 2x squared, we get 2x squared -18 equal to 0. Now this is a quadratic equation. We can solve it by the quadratic formula, or we can just use mod 5-3 in the calculator, and the two answers that we are suspecting to get are -3 and 3. Now we are in a very good situation to find the area. Why? Because look at the sketch again. We have the left intersection point is -3. The right intersection point, which is here, is 3. So my integration will go from -3 to 3. The top function, as you can see, will be the blue function. The bottom function, as you can see, will be the red function. So we just have to write -3 to 3, the blue function minus the red function. Now what do we have? We have -x squared, -x squared. This will give me -2x squared. We have 17, -1. That give me 18. So I get 18, -2x squared. Now what is the integral of 18? It will be just 18x. What is the integral of x squared? It's actually x power 3 over 3. And we keep the 2. So x power 3 over 3, keep the 2, and 18 will become 18x. The last step, we substitute 3 instead of each x here, and then we substitute -3 instead of each x here, and we subtract them. The final answer is 72, and that's the area for this question. We'll go to the next question, which, as you can see, again, I have a parabola, and it looks like it's an open upward because the number in front of x squared is positive. And I have a line. How do I know this is a line? Remember, the degree of x is 1. So this will be a line. So we have a parabola and a line. Now, of course, if we sketch them, we know how to sketch a parabola, we know how to sketch the line, we will get something like this, which looks like most probably we will have two intersection points. How do we find them, the intersection point? Exactly as we just did. We have to make the blue function, which is x squared plus 1, is equal to the red function, which is 2x plus 1. So just have to find the intersection points, and we have to write two functions is equal. Now all what you need to do, move 2x to the other side, move 1 to the other side. We will end up with x squared equal to x, because we have plus 1 will get cancelled with plus 1. Next, take 2x to left side and use mod 5 3 in the calculator, or the quadratic equation, or the factoring, whatever you like. You will get two answers, which is 0 and 2. So far so good. We find the limit of integration. So this number here on the left is 0. This number here on the right is 2. So we have from 0 to 2. Now what is the top function? As you can see from my picture, will be the line. The bottom function will be the blue one. So you get line and the blue one. And now if we just cancel 1 and 1, we get this one. Now you ask yourself, what is the integral of 2x? Yes, you are right, it's x squared. What is the integral of x squared? It is x3, because we add 1 to the power and we divide by the new power. So it will be x3 over 3. Final step, substitute 2 and then substitute 0, which is 4 over 3. And that's what exactly we need for this question here. We'll go next. We have an exponential function, so we have to sketch the area. Now, do you remember the graph of the exponential function? The graph of the exponential function will go, if you look at the mouse, will go from left and then it will go quickly upward like this. Now, if I sketch the exponential function from x equal 1 to x equal 3, it will look like this. It will go from here, it will cut the y-axis at 1, and then will go upward very quickly, dramatically quickly. And this is the area I need to find, which is just an area from the exponential function to the x-axis. No intersection point is needed because I have only one curve here. So I just need to do the integration from 1 to 3 and for the exponential function. 1 to 3 to exponential function. Why there is no bottom? If you go back to the graph, the bottom is the y equal to 0, which is the x-axis. So you don't need to write top minus 0, because anything minus 0 is nothing. So it will be e power x. What's the integral of e power x? It's the formula for e power x is just ex. One time I have to substitute 3. The other time I need to substitute 1. And that's what I will get as an area. So that's the question of the exponential function. Next is a question where again we have two parabolas. One is open downward. How do I know that the blue one open downward? Because there is a negative here. The other one is open upward because it's only the number in front of x squared is positive. So it will be looks like this. Again, there are two intersection points we need to find. How do we find the intersection point? We make the two functions equal each other. Now move x squared together, the numbers together, we will get this one. 3x squared equal to 3, which means 3x squared. Sorry, this should be 3 here. I'm very sorry, here it should be 3. So if it was a 3, this should be 3. Just let me change it for you here. Can't change it, but this has to be 3. Okay, the answers is -1 and 1. So finally we do the integral from -1 and 1, top minus bottom. If we simplify this one, we get 3 minus 3x squared. What is the integral of 3? It will be 3x. What is the integral of x squared? It will be x power 3 over 3. So it will be looks like this. Finally, we substitute 1 and then we substitute -1. The answer would be 4. That's what we get in this example here. Next is an example where we will have the square root. Now you have to remember the graph of the square root. This is one of the basic graphs that we have already seen before, which goes like this, going that way. And with x squared, it will look like this. So the square root going in this way and the parabola going upward. They will meet into 2 points. How do we find those 2 points? We find the intersection. So we make them equal to each other. And now, how do we get rid of the square root? I don't want to see the square root. I square everything. And then I move x to the other side, take it as common factor, and make each one equal to 0. I will get either x is 0 or x equal to 1. So the integral will be from 0 to 1, top minus bottom. What is the integral of x square root of x? We need to write it as x power half. And then we add 1, divide by the number. The final answer will be just 1 over 3. I went quickly here because I'm sure you remember how we do the integration of the square root of x. Now, this is an important question here. Here, I have only one curve, which is the blue curve. Again, this will be a parabola, open upward, and the x-axis. So the first step, you need to find the vertex, because this is one of the standard parabola, which is negative b over 2a. And then you need to graph the parabola, which I've already done it here for you. This is the graph. Now, where is the x-axis? The x-axis is this line. If you can see it here, it's this line here. This line is the x-axis. So the intersection, it's clear, happens into 2 points. So we just need to find it. The intersection, of course, will be the blue function, y equal x squared plus x negative 2. The x-axis is represented by y equal to 0. That's the x-axis. And now that's what we will get here. If we solve it, mod 5 or quadratic formula, we get from negative 2 to 1. So my integral will be from negative 2 to 1. Remember, the top function in my graph was the x-axis, which represented by y equal to 0. And the bottom function was the blue one, represented by this. Now this is straightforward. Integral x squared will give me x cubed over 3. Integral of x will be x squared over 2. Integral of 2 will be just 2x. Finally, we substitute 1, and then we substitute negative 2. We get 9 over 2. That's how we do it. Final question is, again, we have 2 parabolas, but this time I have to start from x negative 4 to x equal to 1. So the best way to do this equation is to sketch and see exactly what happens. Now, if we sketch them, we get this one. From negative 2 to 1, that's my left to right. However, the top and the bottom, they change. So I have to start from negative 4 to stop here. And then again, I start from here, which looks like a negative 3, and end up at 1. So you have top, bottom, top, bottom, top, bottom. So we have to split this into 2 questions. Now, how do we make sure what is the intersection point here? We need to solve the 2 equations that is given to you. How we solve them? We just go ahead and we solve them. We get negative 3 and 3. Of course, I don't need 3 because I will stop at 1 anyway. So the only answer I need is negative 3, which is in that range. So if we go back, that's what we will get. We have to split it into 2 integrals, from negative 4 to negative 3, and the top will be the red and the bottom will be blue. And then after negative 3, remember there is a change. Now the top will be the blue the bottom will be the limit. And we just need to find each integral separately, which is an easy, straightforward integrals. We get the answer is 60.